So the alkyne has the general formula of CnH2n minus 2. So if we go back to our table, you remember with the alkyne, you don't have the one with one carbon, because we said the triple bond has to be between two carbons. So we don't have the name there. We'll have ethine, we'll have propyne, and so on. The same way as we have done with the alkene. You must also check here where your triple bond is, because we need to indicate where the position of the triple bond, where the triple bond is. So it's important to indicate the position. So try and draw the same way as we have done with the alkene. Draw the structure for different alkynes and see where the possibility of the different names of the alkynes that you might have, and put them down there as your possibilities in your table up to number 8. All right? And then we say the functional group, we've got C, triple bond C. This is unsaturated, so it's most unsaturated, unlike the alkene and the alkyne. The alkane and the alkene. Remember, alkane, we said they're saturated. We've got single bonds between carbons. Therefore, it's not possible to break that single bond. That's why we refer to them as saturated. Alkene are unsaturated. You break the double bond to single bond. Alkyne is most unsaturated. The triple bond, you'll break it to double bond before you can break it to a single bond. So these ones, they are most unsaturated as compared to the alkene. Okay, we said you've got triple bond between carbons, and then you only have carbon and hydrogen. So we refer to them as the hydrocarbons. All right? And then how do you name the alkyne? Just like the alkene, you choose the parent name, and this parent name must contain a triple bond in the long chain. So you check that in your long chain you've got triple bond, and then the parent name will end with YME. All right? And then the second step, you number the carbons in the parent name. You number it the same way as we have done with the alkene, where you check that your triple bond has the lower number, just like we have done with the alkene, where we check that the double bond has the lower number. And then from there, if your triple bond is in equal distance from both sides, it doesn't matter which side you start from, because it will contain the same number. And then you place the same way as we have done with the alkene. When you write the name, between the prefix and the suffix, we put the number. So between the parent name and the suffix, we must put the number. Where do we find the triple bond? All right? And then you must also identify substituents. If there are substituents, the same way as we have done, if the substituent contains one carbon, it will end with methyl. And then if it has two carbons, your substituent will be ethyl. So you assign a number to this substituent. But remember, the substituent doesn't determine where you start numbering. The triple bond or the double bond determines where you start numbering. And then if you've got more than two substituents, that is the one that contains ethyl and methyl, you consider the alphabetical order, that E comes before M. And then if you've got the identical substituent of either methyl or ethyl, you put a di if there are two of them, or tri if there are three of them, just like we have done with the previous example. And then the hyphen and the comma, the hyphen between the prefix and the number, and the comma between numbers, that is very important, because you forget it if you are in a hurry and you're excited because you know the name of this one. Let us look at this example that we have. If we look at it, there are 7 carbons on the long chain, and then that's carbon number 1, number 2, number 3, 4, 5, 6, 7. Or we can number it from 1, 2, 3, 4, 5, 6, 7. But if we number it from that side, if you go that way numbering, you see that the triple bond will come after this carbon, which is number 1, 2, 3, 4, 5, carbon number 5. And we know that 5 is higher than 2. Therefore, the blue that you are seeing there is the correct way of numbering your carbons. So we number it from there. And then we identify here you've got a substituent at carbon number 4. Therefore, when we give the name to this one, you look at the substituent. There is another substituent at carbon number 5. And the two substituents are identical. They both contain the same number of carbons. That's why we say they're identical. Therefore, if there are 2, before you write the name of the substituent, you will put di representing 2. And then if there were 3, you will put tri representing 3. So if we have to give the name to this one, we say at carbon number 4, comma, carbon number 5. So we'll have 4, 5, and then 2 substituents that are identical, dash, dimethyl. The parent name has 7 carbons, which will be hept. And then dash, after carbon number 2, you've got ine. Therefore, let's have a look at how the name should be written. We said it's an alkyne because it contains triple bond. So it will end with YNE. And then it has 6 carbons, meaning that it's not 6, it's 7 carbons. Sorry for this. Please correct that. That is 7 carbons, not 6. Therefore, it will be hept. And then the lower number for the triple bond is at carbon number, after carbon number 2. Because you see red says after carbon number 5. So we'll also see the blue for that. So the parent name will be pent-2-ine. But we know that we've got 2 methyl substituent. Therefore, the correct name there is carbon number 4, comma, carbon number 5, dimethyl hept-2-ine. So that's the correct name for this one. Let us look at another example so that we try and get this name and the substituent and the position of the triple bond correct. Let's draw another one here. 1, 2, 3, 4, 5, where here we'll have a triple bond. So let's check and verify that each carbon has enough bonds. 1, 2, 3, 4, 1, 2, 3, 4. So it's correct. And then let's put here the hydrogens. And then this one, it doesn't need any substituent because already it has, or doesn't need any hydrogen because it has, the number of carbons are right. And then let's put a substituent there with 2 carbons and another one there with 1 carbon. Let me put the other carbon there. So this one will have 3 hydrogens. I just want to confuse you. This one we have 1, 2, 3, 4. Okay, that one has, we'll put 3 hydrogens around it. This one, 1, 2, 3, 4. Okay. This one you said it's okay, that one is fine. So if you have a look at this structure that we have, the long chain has how many carbons? If you look at the long chain, you will look at that as the long chain. But this long chain bends. So you just have to be careful that the long chain can also bend. So this is not a substituent. It's part of the long chain. All right? So we've got 1, 2, 3, 4, 5, 6 carbons in the long chain. And then if I go this way, I've got 1, 2, 3, 4, 5, 6. I still have 6 carbons in the long chain. But, okay, no, it will still make sense. All right? But I'm going to take that one as my long chain. I'm going to number it 1, 2, 3, 4, 5, 6. And I'm going to use another color for numbering. 1, 2, 3, 4, 5, 6. So when I check my numbering and where my double bond is, I check the first numbering, the black numbering, after carbon number 2, I've got triple bond. And then the other numbering, after carbon number 4, I've got triple bond. All right. Therefore, the correct numbering that I'm going to choose is the one that gives me the lower number, which is the bottom one, from right to left. So, because I know that this is an alkyne, I've got 6 carbons, so it will end with hex for 6, and then I'll have YNE as my suffix. Therefore, between these two, I'll have the number that indicates the position of my triple bond. And then I check. I've got substituents. I've got that substituent at carbon number 3 and number 4, because he said we take the bottom. Let me just cancel that one because I'm not taking that one, so that I don't get confused. And then at carbon number 4, I also have that substituent. So if I have to write the name for this one, I'm going to say at carbon number 4, I've got a substituent E and M. Therefore, if I remember well, ethyl, methyl. If I remember my alphabetical order, I know that E comes before M. Therefore, this will be 4-ethyl. And then I've got another substituent, and therefore I must put a dash because I need to indicate the position of that substituent as 4. And then 1 carbon, methyl. And then I've got 6 carbons, hex, dash, after carbon number 2, I've got triple bond. All right. So the name for this compound is 4-ethyl-4-methyl hex-2-I. That's the name of this compound.